This research was all about trying to understand when humans started changing the climate through the burning of fossil fuels. So it was really answering that question, when did global warming begin? And the answer that we found was quite surprising. It's really, humans started altering the climate in around about the 1830s. I'm Nerily Abram. I'm a climate researcher. I work at the Research School of Earth Sciences at the Australian National University. So when manufacturing was really just sort of starting off and we were really only just starting to harness fossil fuels, even those small increases in carbon dioxide in the atmosphere were enough to make a measurable impact on Earth's climate. There's some strong regional patterns in the way that this human warming signal first developed. So we see it really clearly in the tropical oceans and over the northern hemisphere continents, whereas in the southern hemisphere it took a little bit longer for that warming signal to really start. The Antarctic is a really interesting place, and as a whole, Antarctica doesn't yet show a clear signal of human-induced climate warming. And part of that is just to do with the way that the circulation of the ocean and the atmosphere works in the southern hemisphere, and that pushes any warming sort of further north and away from Antarctica. Some of the samples are samples that I've actually collected and worked on in the lab, but really this is much of a much bigger project than that. So it draws in work that's been done by thousands of scientists across the world and brings that all together to answer this really big question. It's really important to know sort of how our climate responds, which parts of the Earth respond most quickly to changes in greenhouse gases. And that's really important, particularly if we're talking about how we might rectify problems of climate change in the future, knowing sort of where there could be rapid paybacks if we are able to reduce emissions and even pull some of that carbon dioxide back.
For the average voter, the most important issue, of course, is the economy. Even though Donald Trump has people talking about immigration and other kinds of issues about who uses what bathroom, the primary issue that most people are concerned about is the economy. And 2/3 of the American people believe the economy is on the wrong track. And Hillary's offering no real criticism about Obama, major or even minor. And if you believe that the country's on the wrong track, why is it that you'd want somebody who's essentially running for the third term of Obama to be elected? And the fact is that we are overtaxed, overregulated. The government is too intrusive, and we put on new taxes. We put on a brand new entitlement known as Obamacare on the backs of the American job creator, to say nothing about the unleashing of the EPA and the attack on the coal and fossil fuel industries. You add it all up, and we have the worst performing recovery in the lifetimes of most people. Obama will be the first president to ever to preside over a recovery where not 1 year is 3%. His recovery has been less than 2%. Now that may sound like a small amount, 2% between 3%. But for every 1% of growth, you're talking about 1 million jobs times the number of years of the recovery. So had this just been an average recovery, there'd be anywhere from 5 to 7 million more jobs right now, let alone if this had been a Reagan-type recovery, which was about twice that, at 4%. And Ronald Reagan did the opposite of what Obama did. Ronald Reagan dramatically cut taxes, he slowed down the rate of government spending, and he continued deregulation policies that had begun by the previous administration. Obama has done the opposite, and the opposite has produced the opposite results. So that is the issue that most people are concerned about. Also, freedoms are under assault. Hollywood, academia, and media are all conspiring to brainwash America into believing that there's a free lunch, and these SOBs over there, fill in the blank, whether you're talking about Republicans or the Tea Party or Uncle Tom's, are somehow stopping people from eating that free lunch. And that is the battle that we're fighting, and one of the reasons I believe Donald Trump is going to win this election.
The oceans have to be part of any discussion about climate change.
Climate change is unequivocally happening, so it's not something one believes in, but in fact the facts support that sea levels are rising, oceans are warming, they're more acidic, having big effects on the animals and plants that we depend on in the oceans to produce things like fish for us to eat or the oxygen that we breathe.
We hear often about a so-called pause in global warming. Well, the fact is the oceans never stop. Everything we know about this system suggests that it will accelerate and do so greatly in the next 20 to 30 years.
In the ocean, carbon dioxide is a major pollutant.
We've all heard about greenhouse gases, and as we warm the atmosphere, most of that heat is taken up by the oceans.
We have very good measurements now of heat content change in the oceans. That's the real smoking gun of climate change.
Fisheries and species are shifting, and they're following climate and temperature changes. We actually have fish thinking they're in Baja, but they're really in Monterey. We've had bluefin tuna up here. We've had a number of species that our fishermen have never seen before this far north.
We are changing the chemistry of the entire global ocean with CO2.
Oceans are warming, they're more acidic than they were by a substantial margin.
CO2 is absorbed by the ocean and creates carbonic acid. The same sort of acid that's in soda pop poses some very key physiological challenges for some organisms. Probably the best known is for organisms that make calcium carbonate shells. We all know calcium carbonate. It's the shells we see on the beach in clams, coral reefs. A more acidic ocean makes it much more costly energetically for animals to make their shells and make their skeletons.
But I am concerned that we are currently underestimating the magnitude of sea level rise that's possible by the end of the century. And one of the defenses that many low-lying islands in the Pacific and the Caribbean and the Indian Ocean have against sea level rise is the presence of coral reefs. Corals are under threat like they never have been before. They suffer harm from these higher levels of CO2.
That means the CO2 curve has got to come back down. If you think about the business as usual curve, it's increasing exponentially over time. To the year 2100, it's still going up. The curve that allows the ocean to continue to provide services to people, food and protection and livelihoods, is one that goes up and then levels off, and then by 2100 is beginning to come back down.
If we look at Earth history, when we've seen large changes in ocean conditions, we've seen massive extinctions. And what does that mean for society? It means that we'll have a different ocean. We'll have different resources, and we may not like what we get.
When you're thinking about climate change, it's the relationship between climate change, the ocean, and people that has to be an incredibly integral part.
So the agricultural community, the fishing community, and the conservation community all can benefit from thinking together about what we can do in climate change.
As a society, you know, this is the right thing to do. Let's deal with this. Let's start investing in solutions. Think more about how much food we get from the ocean, how many people live in coastline areas right next to the ocean.
Every other breath we take is produced by ocean phytoplankton. It is essential for us to care about climate change and the role that it plays in affecting ocean ecosystems, because our very lives depend upon it.
There's been 5 major extinctions in the history of the planet. There's the Ordovician, the Devonian, the Permian. There's the Triassic, Jurassic, and then the KT extinction, the one that killed the dinosaurs. It's very difficult to comprehend in deep time, 4.6 billion years of Earth's history. So if you take, say, the history of the Earth and try to squeeze it into a 24-hour clock, where does man fit on that clock? A few seconds before midnight. That's it. We're the new kid on the block.
What we're seeing now is called the Anthropocene, the new epoch. Anthropocene means the time of humans. It's when the impact of humans is leaving itself as a mark in the fossil record of the future. 65 million years ago, that it was an asteroid that struck and caused the dinosaurs to go extinct.
When it comes to the 6th extinction event, we have no problem identifying the cause. Humanity has become the asteroid.
We know weather is unpredictable and extreme events have always occurred. We also know these events are becoming more severe and more common. And yes, these shifts are down to climate change. So what's the science behind all this? Let's start with greenhouse gases. As you probably know, these are released when we do things like burn fossil fuels. When this happens, heat becomes trapped near the Earth's surface, making it hotter here on land and in the ocean. Of course, this means more evaporation, more water vapour in the air, and more heavy rainfall. Some places get less, some places get more, but when it rains, it can pour. While all this is going on, let's not forget the heat. Hotter days mean higher fire risk, especially in drought-prone areas. This extra heat expands the ocean and also melts the polar ice caps, ice sheets, and glaciers. Sea levels rise, increasing the risk of coastal flooding. The dice are now loaded towards more extreme weather. And do you know what that means for Australians? We've lost homes, ecosystems, livelihoods, and loved ones. And the damage is likely to get worse. So what can we do? We need to prepare to live in a world with more intense extreme weather. This is the critical decade to shape the world we live in and stabilise our climate, protecting our children and grandchildren. And we are the critical people. Find out more at climatecommission.gov.au.